What's up, math fans? In honor of Sweater Fridays, I'm going to open with a joke. My joke is about a plan. I'm going to start with a plan. Plan, all right? So I got P, L, A, and N. Now watch what I do. I'm going to do this, and then I'm going to do this. And that's going to give me PA plus PN. And then I'm going to do this, and then I'm going to do this. And that's going to give me LA plus LN. And now I don't have a plan anymore. My plan has been foiled. My plan has been foiled. Get it? Foiled? All right. Well, if you are good at FOIL, you are also going to be good at factoring. And this is all about factoring, all right? So it's called reducing fractions with quadratics. So you should know the vocabulary here that a quadratic usually looks like this. Something, A represents a number. You'll probably see a number there. And if you don't see a number there, like right here, if there's no number, it's still a number. It's a 1. You knew that. You've seen my old videos. So you're going to see something like ax squared plus bx plus c, where there's a number here, and a number here. So in this case, A is 1, B is also 1, and C is -2. The point of a quadratic is as long as you see an x or a variable squared, if the highest exponent is 2, it's a quadratic. So quadratic, even though this one is not in this form, it kind of is. Here, A is 2, there is no B, and then the C is -50. So it's still a quadratic. The highest exponent is 2. Also a quadratic, highest exponent is 2. Just backwards, don't be scared. And also a quadratic. All right? So I want to know how to reduce fractions with quadratics. All of these are quadratics. Another word for reduce is simplify or find the quotient. Quotient just means divide. So basically you're dividing. All right? So here's a quick warm-up for division. I know you love the joke. I got to get rid of it. Look at part A in my warm-up. Part A says, what's 5 times 4 over 5 times 2? Also known as 5 times 4 divided by 5 times 2. That little line means division. So if you do it the long way, you get 20 divided by 10, and 20 divided by 10 is 2. However, if you look at this, I have common factors here. I can cancel my common factors. 5 divided by 5 is 1. And then I have 4 divided by 2, and 4 divided by 2 is 2. So I get my answer 2 right away. Don't have to do it the long way by multiplying it out, and then dividing. You cancel common factors first. Oh, but Professor Noy, what about the 1? Well, 1 times 2 is still 2. So that 1 doesn't affect the final answer. Check this out. Based on what I just said, wouldn't you cancel out the common factors and put a 1 here, and cancel out the common factors and put a 1 here, and then say, well, this answer is 1 plus 1 is 2? Nope, nope, because listen to the vocabulary. You're only allowed to cancel out if they're common factors. These are not factors because this is not a multiplication sign, it's a plus sign. So you're only allowed to do it if it's a multiplication sign. You can't just randomly cross it out here. It's very different, and I'll prove it if you do it the long way. 5 plus 3 is 8. 5 plus 3 is 8, and that, now I can cancel, and that gives me 1, not 2. So this is slightly different. Here, again, you cannot randomly cancel the 5s and randomly cancel the 3s and say the answer is 1 plus 1, or actually, here it would be 1 minus 1, which is 0. Nope, no. Watch, do it the long way. 5 plus 3 is 8, 5 minus 3 is 2, and 8 divided by 2 is 4. So you didn't see that coming. So for addition and subtraction, you actually have to do it. Only when you're multiplying, you cancel out the common factor. All right? Now I'm going to use that for the next 3 problems. So if you look at number 1, and they say simplify or reduce or find the quotient, I want to, oh look, I can just cross out the x squareds, right? No, x squared is not a factor. It's connected to the rest of this trinomial by that plus sign and that minus sign. It's an entire thing, it's an entire entity. So the only thing I can do to break it up is to factor it. Good thing I'm good at FOIL. So I know that my factors look like this. I know I need an x and an x. and I know I need to find the factors of -2. My only choice is really 2 and 1. I just got to figure out where the sign goes. So I believe the bigger number gets the middle sign, so that's +2 and that's -1. Now let's go down here. This is actually considered a perfect square trinomial. Why? Because here the factors are the same. If the factors are the same, it's considered a perfect square. So again, you got x and x, and this is easy because they're both plus signs, and the only thing to give me 4 is 4 and 1, or 2 and 2. I'm going to go with 2 and 2 because 2 plus 2 is 4. Remember, the product has to be 4, the sum has to be 4. So this is 2, and this is 2. Same factors here. Now that I have the same factors, I can cancel out common factors. The entire x plus 2 can go with the entire x plus 2 because that's multiplying now in the middle. So now we're good. We cancel out the common factors, and whatever's left is your answer. And notice you cannot cross out the x's here because these are not factors. They're connected with the minus sign. This is connected with the plus sign. The x is married. The minus sign is like the wedding ring. They're married. Don't break up the marriage. Here, you're allowed to break up the marriage because there's no plus sign in the middle or minus sign. That's multiplication. It's okay. I'm going to do this one. Let's start with the bottom one because you're expecting it. All right? My factors of 15 are 15 and 1 or 5 and 3. Which one do I use? 5 and 3 because 5 plus 3 is 8. So this is x plus 5 and x plus 3. Here's a secret that I haven't really made clear. You should know this. I'm so used to factoring using the sum product method that I never even pointed out that before you even go to the sum product method, when you're factoring, you should look for something called the GCF, the greatest common factor. And I have a video about how to find the greatest common factor. Please review it. If I look here, there's a GCF. There's something that goes into both 2 and 50. It's 2. Take out the 2. What's left? X squared minus, and if I factored out a 2 from 50, factoring is like dividing, then I'm left with 25. Alright, so this is a fun problem because there's another step. You might hear this as factored completely, meaning I have to factor again. So this 2 is going to carry over, but then I'm going to look at this and say, oh, I know that. I saw the video on dots, D-O-T-S, difference of 2 squares. And what do? Well, this comes from conjugates, x plus 5 times x minus 5 over x plus 5 times x plus 3. And look at this, common factors, goodbye, goodbye. Final answer is 2 times x minus 5, right? Whatever did not get crossed out, over x plus 3 on the bottom. So this is a fun game of breaking it apart and canceling it out. That's it. It looks complicated, it looks like a lot of work. It is, it's a few extra steps than you're used to, but as long as you know FOIL, it's really the same thing. It's just backwards FOIL. One more. Again, oh no, it looks scary, but it's exactly the same as all the other ones. How do I get this? Is there a GCF? No, so let me go straight to sum product. On the bottom, straight to sum product. All right, I'd like you to actually try this one on your own. So you could probably end the tape now or the video now, but if you're curious, stick around. Here, instead of x squared, first I need a 48. So I'm thinking, there's a bunch of things. 24 times 2, or 8 times 6, or 12 times 4. And I planned ahead, so I know it's 12 times 4, and you'll see why. Here, I need a plus x and a minus x, right? And I'm not sure, so I'm going to do FOIL to see if I was correct. But in the middle, I need a plus 8. So actually, in order to get that plus 8 in the middle, I need this to be a minus and this to be a plus. And when you do FOIL here, you'll see why. On the bottom, I have x plus, let me see, what gives me 12? 12 and 1, 3 and 4, 6 and 2. Which one do I use? I need a plus 1 in the middle, so 3 and 4. Plus 4, x minus 3. All right? Now, do I have common factors? Yes. Even though these look different, if you switch this around, and you're allowed to because of the commutative property, these are the same. Goodbye x plus 4, goodbye x plus 4. Final answer is 12 minus x over x minus 3. Okay? So, that is how you reduce fractions. It's basically just a lot of factoring. When you factor, you want your GCF first, then you look for sum product method, or you look for a difference of two squares. So you use all your skills at one time. These are great practice problems to put all your skills together. Thanks for watching. See ya.